Hello, everyone. Welcome to SEMLA 2021. So this is part of a series of webinars on software engineering for machine learning applications. So they are hosted by IVADO and Polytechnic of Montreal. In total, we have 6 talks across a month time. Previously, we had 4 talks by 5 speakers. And on this Tuesday, we just had an interesting talk by Danilo Sato and Arif Wider on continuous delivery for machine learning. Today, our speaker is Dr. Yingnong from Microsoft Azure. His topic is about AIOps from research innovations to industrial adoptions. I will first briefly introduce Dr. Dang. So he's a principal data scientist manager in Microsoft Azure. Maybe later you can tell us how to correctly pronounce Azure or Azure. His research focus is AIOps and its industrial adoption. He has been advocating the importance of AIOps in industry and academia. Previously, he was a researcher in Microsoft Research Asia with research areas in software analytics, data visualization, data mining, and human-computer interaction. And before moving to the talk, I want to remind the audience to ask questions using the room's Q&A channel. Please also vote for the questions. I will relay the questions to the speaker after the talk. We are also streaming the talk on YouTube, so you can also ask your questions through the YouTube live stream channel. And you can raise your questions during a speak or after a speak. Okay, let's, without further ado, let's welcome Dr. Dang.
Thank you, Professor Lee. Let me share my screen. Can you see my screen now?
Yes.
Okay, cool. First, I want to thank our seminar organizers to invite me to this talk, and especially Professor Lee for the coordination. It's my honor to be here to share and learn with all the people here. And so as Heng just introduced, and I have been working for Azure in the past few years from 2013. Before that, I have been a researcher in Microsoft Research Asia Lab, located in Beijing, China. I view that the research experience and the production group experience is give me a very unique perspective to look at the problem in this cloud computing area. So I'm very happy to share and learn with you. And so today's agenda, I will first introduce the basic concept of AIOps, and then share the 5 principles we abstract from what we have done in this area about building AIOps solutions. And then I will share 2 case studies, and then I will list a few open research questions so that the research community can also contribute to this area. So let's start the story from the what happened in the software industry in the past 10 to 15 years. And we see a clear paradigm shift to the cloud computing. And as we know that digital transformation is happening, all the industries are embracing the digitalization and embracing cloud computing to transform their business. We can see many industries like healthcare, like gaming, like e-commerce, finance. They are all embracing cloud service for their business. And as we show here, Gartner have some numbers to tell us what happening. So in the left side, this is about enterprise IT spending change. We can see that cloud computing investment from enterprises has been increasing from 3 years ago until now, and will continue to increase. And from the right side, we can see that the end user spending to the cloud computing, cloud services also continuously increasing from BPaaS, which is business platform as a service, PaaS, platform as a service, SaaS, software as a service, IaaS, and infrastructure as a service, DaaS, which is data as a service. So the market is huge. That means that we need focus more on, as a research community, how we can build a better cloud computing to help the whole industry and society to better utilize cloud resources. So given the importance of cloud computing, let's further look at what the nature about building and operating cloud services. And if I use 3 keywords to summarize, it will be skill, complexity, and ever-changing situation. And it's obvious that skill is huge. That every company, small company, big company, they can very easily reach a huge customer base. And the computing resources can be very easy to be scaled up. And complexity reflected by the diverse needs and the complicated interconnection between different services. And changes also reflect in these 3 dimensions. Customer needs are always changing, and online infrastructure, whatever kind of service you are building, BPaaS, PaaS, the service depend on underlying infrastructure like IaaS, and even the IaaS vendors like Microsoft, Amazon, they depend on the data center, physical data center, internet connection, etc. And the situation is always changing. And the service ecosystem, you are building a service, and your service need to call other services to achieve the goal. And these services are also dynamically evolving, and that's all about the changes. So the fundamental problem for the people, engineers, to build and operate the cloud service and skill is about how we can deliver high quality and efficient service with ever-changing needs, infrastructure, and dependency. And we realize that the traditional software development approach may not fully fit the needs. Okay, if we further click on the positive needs on the process of building and operating cloud service, we'll realize that the data-driven decision-making happens everywhere. Regardless, it is about the design decisions, DevOps process, like should I release the new build? Is the quality of my service is good enough to go broad? How can I fix this bug? Should I indicate the customers to do any change? System adjustments due to changes of workload and environment, like okay, the customer traffic get increased. Should I allocate more computing resources to the services, etc.? And engagement with customers, which is also important, that customer call in and ask for support. How can I quickly identify what exactly customer complaint? Is it a platform issue, or it is the usage issue from customer side? It's all decisions that cloud computing engineers, operators need to make, and this is not an easy task. So given the skill complexity And the progressive needs of data-driven decision-making, we find that naturally AI come into the picture. How can we leverage AI to all this decision-making in this complicated environment and scalable service? So we propose that AIOps is about infusing AI to all aspects of development, building, and operation of cloud services. And AIOps should benefit the trinity of cloud computing, which is about service system, customers, and engineering. And so how AI can help this trinity, let's go further. So let's first talk about AI for systems. And we would envision that the cloud computing systems have a paradigm shift from manual and reactive to the change, a different type of the change, to automated and proactive approach, which align to the autonomic computing idea. So the service should be able to self-manage itself and self-adapt to itself. And the key is that the service has the capability to detect and predict changes about the customer needs, about the infrastructure healthy, and the dependencies. And this kind of self-awareness and even know what will happen in the future, that gives services the potential to self-adjust the knobs and mitigate the issue before it happens. And the value of such AI capability is clear, that we will have increased the system quality, efficiency, and resiliency. And importantly, it will reduce the costs through efficient use of resources. COGS means cost of goods sold. And because there is more autonomy and the manual operation costs get reduced because there's minimized needs on the manual operation. And there's a lot of research questions in this area. Predicting the change, detecting what's happening, what expected, what unexpected, and this is about anomaly detection, failure prediction, capacity utilization prediction, etc. And also based on the awareness, the judgment of the current situation and the prediction results, how can we design adjustment and mitigation schemes and to protect the customers and make sure the efficient usage of the resources is another big area for research. And let's talk about the AI for DevOps. And we would see that data-driven approach could be better enhanced to be insights-driven, which means that because the volume of data is so huge, and looking at the raw data to make decision will never be efficient. And we want to envision that provide insights in the fingertip of engineers so that they can quickly consume it and make decisions about bug fix, patch, customer notification, etc. And the value is also clear, that we empower engineers to focus on real problem solving instead of looking at the raw data, tediously find out what they need to make decisions. And we'll have increased the velocity of feature and value delivery to end users. And of course, this is reduce the DevOps cost. This is a huge research opportunity in this area. This is kind of aligned to the current software engineer research agenda, but with the focus of how we can apply the existing software engineer research to the cloud computing area, given the scale and the complexity of the problem get changed a lot. So for example, how to find highly accurate and relevant insights that engineers need in the context of the task in the hand. and how to support the decision-making process of engineers. So the last one is AI for customers. And we would envision that the customer engagement to the cloud service should shift from purely reactive to be more proactive, so that we can minimize the customer uncertainty. We want to get awareness of customer pain before customer get aware of it, and instead of customer ask support to the service provider proactively inform customer, hey, something wrong happened and we are fixing it, and you have some kind of the mitigation workaround options and we can provide something like that. And the value is that we'll have increased the customer satisfaction and reduce the customer churn, because customer get better trust to the service provider, and of course reduce the support cost. And the research question in this area is also a lot, like how can we effectively, accurately sense the customer pain? It's not trivial to understand what customer is doing in the constraint of keeping the customer privacy in the mind. And also want to predict the future needs of customers to be prepared for new features. And again, customer privacy is the first priority in this area. So let's look at the data in this area that we need to consume to build, to extract insights and build AIOps solutions. And we can see that there's a very diverse data that available for us to build any AIOps solutions. It's about the service behavior data. It's about customer behavior data and the engineer or the operation artifacts. And the characteristics of the data in this area is quite different with other machine learning AI application area like speech recognition, NLP, etc. The data in this area is huge and heterogeneous. There are very different type of the data that reflect what's going on. And labels are always lacking because it's hard for us to get labels from developers about what's going on. And data quality is always an issue, and change is always happening. And interpreting the data is also not that straightforward. A lot of the domain knowledge is needed to even understand the data. So let's revisit, okay, we have such kind of the data set available in this area, and we talk about the progressive needs of data-driven decision-making in 3 different areas. And we can summarize the challenge in this area to the engineers for us to build better intelligent solutions for cloud computing. And we summarize there are 5 types of the challenges for the researchers and the AIOps practitioners to tackle to build AIOps solutions. So the number 1 challenge is the problem. The problem in this area is always diverse. There's no such a few well-defined problem that everyone can tackle, like image recognition, speech recognition. The problem is relatively well-defined. In this area, typical problem like anomaly detection. And you will see that anomaly detection is a research area. Yes, it is. But it is a very big area. Anything unexpected happened in the service, in the customer, is anomaly. And detect anomaly is about detect. It's not that you can just use one single approach and can solve the anomaly detection problem in different scenarios. And we talk about the data challenge, large volume, highly noisy data. It's obvious, and I will not talk too much about that. A decision. So the decision making in this area need quick turnaround, like hotfix, like suggest customers to do workaround, etc. If you cannot provide timely recommendations, making timely decisions, you will lose the business. You will have something damage the customer experience. This is about faster decision. And knowledge is another challenge that, as I just mentioned, that interpret the data point in this area is not straightforward. Also, knowledge silos is always there, as in a cloud service world, and everyone work on their microservice, and it's hard for everyone to know other microservices detail easily, so that when live site investigation happen, ticket travel across different teams is very common, because no one knows the whole, and the team only know that, oh, this is my issue, or this is not my issue. If it is not the issue by my microservice, I have to handle it to other teams based on my best guess, and it's not reliable, and it is very time consuming. And the last one is the process challenge. And we do have data-driven build and operation process. And this process may have limitations to easily support us to plug AI capability into it. And we do need careful consideration to do the integrated innovation so that we can enhance the process. Of course, AI cannot solve all the problems in this area, and we need the engineering excellence, and we need engineers to do the basic software engineering in the right way. Otherwise, AI cannot help, actually. And knowledge sharing is important for engineers to make right decisions. And still, the skill and complexity calls for AI to help. Because even best engineers with full knowledge, the problem is so huge, problem space is so huge, and complexity is so high that we need AI to help knowledge representation. We need AI to learn from large and help us to make smart decisions. Okay. So based on our experience on building AIOps solutions in the past few years in Microsoft Azure, we would like to propose 5 principles for anyone to build AIOps solutions. And the first one is mindset shift. And I will talk more details about mindset shift in the next slide. And here I want to elaborate more about the other 4 principles. The second one is clearly define the problem, user scenario, evaluation criteria. This is aligned to the challenge I just mentioned, that the ad hoc problems in this area is the case. And we always need to clearly formulate the business problem to analytics problem what's the input data, what's the output, etc. And evaluation criteria, including both that how we evaluate the model from the model perspective, for sure, and also we need to evaluate the value of the whole end-to-end system from the business perspective. So in many cases, criteria like precision recall is not enough. Other metrics like what's the overall customer pain reduction will be in the picture. And data quality assurance as a principle is obvious, and I will have some examples to further elaborate this one. And the model challenge is about that it's hard in this area that we can just leverage off-the-shelf machine learning model, supervised learning model, unsupervised machine learning model to solve the problem here. And the key is that there's a lot of the domain-related situation that we need to encode such meta-knowledge into the model. Otherwise, it's hard to have model generate valuable and actionable insights. And the last principle is about we need to always build an integrated solution. The solution need to be either part of the system itself or part of DevOps process. And any isolated model application is hard to generate sustainable value for the cloud computing. So let's go back to the first principle. It's about insight and action-driven mindset. So we view that this is always the paradigm when we build AIOps solutions. We always start from data, regardless it is customer behavior data, system data, or DevOps process. And we use AI to extract knowledge, extract insights about the system, about the customer, and the DevOps artifacts. Detection, diagnose, prediction, optimization. This is for type of the insights we can derive. And we always want to have the insights associated with the impact metric. The impact metric help us to interpret the meaning of the insights. And the insights should always generate actions. And the actions could be mitigation, could be some adjustment to avoid future pain, could be optimization about the configuration and the usage, and could be the even overall system architecture change and process change. Again, the actions we generate should always be associated with the value metric. Because we take these mitigation actions, we reduce the customer pain by these numbers, something like that. And seeing this, measure everything is important. Measuring the insights, measuring the actions, measuring the service KPIs for sure. And integration with system and DevOps process, as I just mentioned. And the last point is the feedback loop, that as the system is always evolving, and we need to have the model to catch up to the change. And we should always actively seek feedback from engineers, and always continuously evaluate the system behavior and the model behavior, and continuously improve or end-to-end system. So I just show what AIOps is about, and also propose 5 principles of building AIOps solutions. Now I would like to share one case study, how we apply these 5 principles to build a system, help rolling out changes to millions of machines without regressions. So this is our work that we presented in NSDI last year. This is joint work between our team and researchers from Microsoft Research Asia Lab and professor from Johns Hopkins University. So let's start from overall Azure architecture. So as we know that Azure is the cloud computing platform Microsoft provides. Azure started providing service from 2011, which is 10 years from now. And there's a multi-level of the stack in the whole stack that we, Azure has the Azure Resource Manager layer and allow customers to ask for resources to Azure through portal or library or third-party library to call Azure Resource Manager to ask Azure resources. And Azure Resource Manager will call different type of the resource provider, like network resource provider, disk resource provider, to allocate the resources. And this resource provider will call into Fabric controller and hardware manager to ensure the right computing resources get allocated to the customers. And then the physical machines are on the bottom to provide the virtual machine resources and etc. Now let's drill in a little bit more on the compute architecture. So overall, Azure provide 3 types of the service: computing, networking, and storage. So let's look at the compute architecture. As we said, there's Azure Resource Manager, and there's a regional level resource provider. And then at the cluster level, we have a few managers to manage different type of the resources. And then in every physical machine in Azure data center, we have multiple agents running in every physical machine to manage the resource in every physical node. And of course, there's a guest OS running in the virtual machine to provide the computing environment for customer workload. So this is the context of the Azure computing environment. Now let's talk about why safe deployment is challenging. So the point is that as I just showed, there are many components, microservices running at different layers in Azure Stack, and they all need frequent update for new features, for bug fix, etc. And there could be operation failure, timeouts at the regional level service. It could be more type of the failures at the physical node level, node reboot, agent crash, etc. And especially because all the services are interconnecting to each other, update one service may impact the service quality of dependent service because of the contract broken, because of risk condition, etc. There are many different reasons that causing the safe deployment is very challenging, because you never know which component causing the failure. The same operation failure may caused by this layer component having an issue, or underlying layer, or on the bottom layer. It's very hard to articulate the source of the failure. So the existing practice in Azure to to roll out new features of any component to the broad fleet. Azure has more than 60 regions across the 5 continents, and roll out in a new feature to millions of machines need a lot of regulation. So far, we have 3 layers. Firstly is pre-qualification testing, which is kind of the integration testing to ensure the basic functionality always working. And the limitation of this pre-qualified testing is that the testing environment is hard to cover all the settings situation in the production workload, production environment, because the production environment workload is more rich and diverse, and the hardware diversity in the production may also be much higher than in the pre-production environment. If we do not testing it in some hardware, it's hard to see everything will work naturally well in the new hardware. And on top of the pre-qualification testing, we have a safety department policy to preventing block radius of the plane. Like if there are 2 regions in the same 2 data centers in the same region, or the pair regions that many customers run multiple replicas in different regions, we do not allow in parallel rollout of the new features to these 2 regions to make sure that in case there's issues of rollout in one region, the backup region the customer is using is always working. And the third layer is local watchdog, which is efficient to capture immediate issues. But still that there is a big gap that global issue or latent issue happen hours or days after deployment cannot be captured by the existing mechanism. So that's the reason we propose to build an intelligent watchdog to capture global and latent issue. And the overview of the model is comes here. And on the essence, we have 2 models. One is correlation model to find out the failure events mapping to the update events through anomaly detection, through ensemble voting to assign, to find out which component update has higher probability causing the failures, and also doing spatial and temporal correlation. Due to the time limitation, I will not go into details of the model. If you are interested in, you can read our papers in NSDN 2020. You can just search Gandalf NSDN, you will get the paper. And implementation-wise, we need to detect both immediate and latent issues. So we have a Lambda architecture, and to have a speed layer and a batch layer. Speed layer to to capture the immediate issue like happened within 1 hour, and batch layer look at all long history to find out all the latent issue. And we also have an interactive dashboard to help developers to consume our results. Our result is about, oh, this build is bad and you want to stop it, and or we automatically stop it. And we provide supporting evidence to such a web front end so that developers can easily consume it. And we have very good adoption to in the Azure infrastructure teams, and help Azure improve the overall availability in the past few years. So let's see how we apply the 5 principles to build such an AIOps solution at the scale of Azure. And the first one is insights and action-driven mindset. And so the insights we generated here is about all this component being rolled out is suspicious because of the failure happened more often after the deployment, something like that. And we always highlight the actions we take, we can enable. In this case, it's about automatically notify rollout orchestrator to stop the bad rollouts, notify release managers to confirm the issue and investigate. The second principle is clearly define the problem and evaluation criteria. So we formulate the basic problem to analyze problem, which is a correlation problem and a prediction problem. And the evaluation criteria include both precision recall and the customer value. What's the total customer interruptions we avoided because of the failures generated by the bad rollout get averted, something like that. The third principle is uphold the data quality. And without high quality data, it's hard to generate high quality decisions. So we handle with data missing issue, data latency issue, and we also need to handle semantic issue. To what extent a failure impact a customer and how. And this is involve huge effort and continuous effort to ensure the data quality. And the fourth principle is about encoding domain knowledge into the models and AIOps solutions. And we need library domain knowledge to help us to do data cleanup. And we need library domain knowledge to make sure the model fits the domain needs and assess the customer impact based on the customer impact to optimize the model parameters, etc. The last principle is building end-to-end solutions as integral part of DevOps process. And we need to hook up our no-build decisions with orchestration service to enable automatically stopping the bad rollout. And need to hook up with alerting services to notify engineers to look at the issue immediately. Okay, due to the time limitation, I will quickly go through the second case study and try to finish in 5 minutes so that we can leave 10 minutes for questions. So the second case study is about predictive and adaptive failure mitigation to avert production cloud VM interruptions. So the problem we want to solve here is that infrastructure as a service, the virtual machine service for customers. But the hardware failure, firmware failure, like disk, memory, CPU failure in the physical node will cause interruptions to the virtual machine, because disk failure will cause node reboot or node host OS crash and VM will be interrupted. To reduce the hardware failure, firmware failure impact to the customer VM interruptions, we have this project Naya to do predictive and adaptive failure prevention. The key is to predict the hardware failures, and after the prediction, we use online learning, A/B testing, and multi-opt banded decision to adaptively find out the best mitigation actions, such as live migrate to the healthy node before the failure happens, or just block the allocation of new VM landing to this suspicious node if we have low for the failure prediction results, etc. I will not go to the detail. If you are interested in, you can search Naya and OSDI, you can find a paper. So the learnings in this project is that prediction, machine learning can go wrong, and we cannot expect 100% failure prediction to be correct. And handle the false positive is the key to the success of this project. And of course, data quality is critical. Without high quality data, we cannot predict the result correctly. So in the last 4 minutes, I try to show a few open research challenges based on my understanding, so that the community can also think. So the fundamental problem in the AI area is about understanding, predicting, and manipulate highly complicated and dynamic system. Changes always happen. And if we build a machine learning model to predict, the model should always be updated. That we can never have static labels for us to build the model, and we cannot have one model fit the needs forever. And making dynamic systems always performance highly reliable and with high efficiency is fundamental problems we need to solve. And machine learning problems in these areas, including both unsupervised learning, and the patterns in source code, in change, in build, in runtime logs, is always complex. And I believe that many software engineer researchers working in this area, and how to apply the existing research result to the cloud computing settings is a challenge. The key challenge is the skill of the logs and skill of the problem. And supervised learning in this area is also challenging because of the learning target is already changing. If we do the disk prediction, there's always new disk models by the storage vendors, and we never have reliable labels. And in the production environment, the label is extremely imbalanced always, etc. And another big area is the research about infusing AI into systems and making sure intelligent component working reliably in the system infrastructure. High challenge that how we can step by step replacing existing static knobs to be learnable, and etc. Cost function, cost of validation, doing A/B testing, infrastructure layer, etc. It's all challenging, and we need to generate an explainable and debuggable model. We need to convince developers what's a bad thing happened. So the last one is that we need more research of AI technology to empower engineers, including developers, program managers, operation engineers, etc. And we need to build new capabilities to support all different productivity scenarios and highly precision and good recall, etc. In the past few years, we also organized a cloud intelligence workshop in AI and ICSE, and advocating cloud intelligence and AIOps research. And AIOps originally defined by Gartner 2017, and we actually proposed indeed the concept of AIOps. So I want to stop here. Sorry, I'm rushed up, and I do want to leave 10 minutes for questions. Thank you.
Okay, thank you, Yingnong, for this interesting talk. It's time to ask questions, and please raise your question in a QA channel or YouTube. So we have an audience. Yeah, we have many audience in YouTube channel as well. First, I want to ask a question. It is about so what are biggest challenges based on your experience, the challenges for transforming like the machine learning based solution or AIOps solution into production?
I think the biggest challenge to me is two. And number one is problem formulation. And the software engineering development world and data science world is two different worlds. And when we talk with software engineers, they are using their language, and they always try to using engineering approach of problem. And they describe the problem in the way that in the terms they are familiar with. And we know there is a problem, and we try to help, but we need first to fully understand what's the problem. And then we formulate the problem to the analytics problem, data science problem, and we can solve it. I find out that in my real daily work, I took a lot of time to really understand the problem. So this is number one. That's also the reason we put that problem formulation as one principle for building app solutions. And the number two is the data quality, data availability. Because originally, developers instrument their services just in mind that, oh, one day maybe I need to debug some specific cases. There's no mindset to say, oh, I need to systematically instrument my services so that we can build AI to extract patterns and find out insights to me automatically. So there's a big gap between the existing instrumentation logs and data needs for us to build machine learning models.
So the biggest challenges are like either to define a problem or like to find like high quality data to build a solution, right? Yes. Okay. See, another question is so you mentioned because so when we apply this machine learning based solutions in production, we expect many false positive or like false negative. It's not always 100% accurate. So how did you handle these cases?
Yeah, very good question. And especially I mentioned a little bit about the hardware failure prediction in the second case study. And it's true that if we can even have 50% of the precision, it is very good prediction, because if you think about the original label, which is about that in the production environment, the real failure happened in 1 out of 1,000 machines in 1 week, something like that. If we do random guess, we'll get 0.1% of the precision, or even 0.01 precision if we do the prediction every 1 hour. Now, if we have 50% of precision, this is 100 improvement of the prediction result accuracy. But still, that 50% means that we still have 50% false positive. And I think in this case, the issue is that if the false positive, oh, this node will be bad, and it's accurate, it will not be bad. We ask for migrating the workload in this node to healthy node. But it turns out that this node is still working fine. So the cost is the capacity cost. And so when we build the multi-banded model, we actually incorporate the capacity cost into the model. Mm-hmm. But in general, that availability concern is #1 concern compared with concern. but there is a balance, a trade-off that we need to consider both in the cost function, and this way we can handle it in a reasonable.
Okay, so basically it's based on the cost. So you
Yes.
charge whether it's like the benefit outperform the cost, then you use this result, right?
Yeah.
Okay. There's a question from home. His question is that like, so how do restrictions imposed on data connection by like regulation agencies like GDPR affect AIOps activities? Do you handle issues related to privacy, confidentiality, etc.?
Thank you, Professor, for the question. This is a very important question. And in Azure, we keep the privacy as a high priority. So there is a dedicated team within Azure scanning all the data store and follow the GDPR guidance. And they have weekly update to every team. Or you have some PI related information, you have something need to handle, and typically that you need to have the right tag to every data point. See, this is related or not, and other than no, okay. So given this, this mechanism ensure that we as engineers will not touch the customer related information, and in case we need to touch, there is we need to follow a process to do that. So that's the way we handle the privacy issue.
I think the time is almost up. I think we can conclude the speak. So thank you again, and Dr. Yingnong for your interesting talk.